there, folks. Today we're going to look at these statistical measurements, but we're going to look at them from the perspective of doing them on a graphing calculator or using something like Desmos. So we're going to let the computers kind of take over and do these things for us. We'll look at all of the statistical measures that we've talked about, mean, median, that kind of thing. We'll even see like the quartiles back from Algebra 1 and that kind of stuff. We're kind of going to focus on this variance and standard deviation, though. Okay? And so again, when you look at variance and standard deviation, we're measuring how spread out the data is. And this, we're looking at the sample. When we're looking at a sample of data, these are the formulas used. If we want the entire population, remember the entire population formula, we essentially just get rid of this guy. Okay? And I mention that again only to point out that we'll see both of these on the calculator. And when we see them on the calculator versus something like Desmos, when we see them on a graphing calculator, the one labeled as sigma will be for population. The one that we actually want, the sample, will be labeled in a different way. All right, and so it's important to understand that there are two versions of this thing that the calculator is going to present to us. We want the one for samples because we're typically dealing with a sample set of data, not the entire population, okay? And so we just have to understand the difference between these when we start plugging these things into the calculators and to the computer and that kind of stuff, all right? Know that there's two different versions. Know which version that we're looking for here, okay? And so taking a look at this example that we've kind of already looked at once, but this time we're going to do the variance and standard deviation, and we're going to do it using the graphing calculator here. So here's how to do this on the TI graphing calculator. The first thing we're going to do is we're going to hit this little button that says stat on it. We could plug this in and do the formula by hand, but I want to show you how to do it on the calculator. Plugging into formulas is literally just that. It's just plugging away. Everyone should be able to do that. I want to show you how to use the calculator to do this. So we go to stat. The first thing we do when we get to the stat menu is we're going to hit edit. We want to edit the information that's in the calculator. And that brings us to our list here. We're just going to punch these values into list 1. If you already have a couple values in the list like this, you can go up and delete each individual value here. So like the 3, if that's highlighted, you hit delete, it'll be gone from the list, and then you can delete the next one. If you want to clear the whole list all at once, you highlight L1, do not hit the delete button, hit the clear button, and you'll see it disappear from down here. It'll disappear the rest of the way as soon as you go back down into the list, okay? If you delete the list, it'll be gone permanently, and you have to run the setup editor again. It's a whole thing. You don't want to do it. So don't delete a list. Delete individual values, but clear the list, okay? And so now let's punch all these values into list 1. And so I have all of my values punched in here. And once I have those values punched in, I'm going to go back to the stat menu. So over here, stat. I'm going to go over to calculate, and I'm going to calculate in one variable statistics. So I hit one variable statistics, and that's because we're only looking at one thing. We're looking at bowling scores, and that's it. These aren't paired up with anything else. So one variable statistics. If you have a newer TI calculator, it might ask you to confirm that you want it to look at list 1, that kind of thing. And then you might have to scroll down to the word calculate. For our purposes for this one, I just hit the enter button again, okay? And so it kind of gives me this list of information here. The very first thing you should notice is that the first thing listed is that X with the bar over it. And then X with the bar over it, well, that's our mean. That's the symbol for mean. So I'm going to copy that guy down. So let's copy down the mean. And we already calculated the mean by hand earlier, but here it is thanks to the calculator. The next thing that it looks almost like a pointy capital E with an X next to it. That is uppercase sigma. And that uppercase sigma of X, that means the sum. So these are the sum of all the X values. In other words, the sum of all the data values. The next one, that's the sum of all the data values squared. And then the next two, these two are both this S with the X and this sigma, which is that symbol we saw earlier with our formula. Those two both represent the standard deviation, okay? However, this S with the X, that's the sample standard deviation. This second one, sigma X, that is for the population, okay? So the one that we're looking at is this SX, so the 29.11. And notice I'm still going to use the little sigma symbol. It's like a 0 with a little hat on it. All right, that's the lowercase sigma. I'm still going to use that for my standard deviation. The thing that the calculator doesn't give me here, and maybe you realized it already, but it doesn't give me the variance. All right, so for this one, the variance is not given. What we have to do is we actually have to take this value, the 27, for our purposes, the 29. So the 29.11062643. And we actually have to square it, okay? When we're doing the formulas by hand, typically we'll find the variance, and then we'll take the square root to get the standard deviation. But when we do it on the calculator will give us the standard deviation. We have to square it to get back to the variance. So 847.43. And again, I'll label that as sigma squared for this one, okay? Couple other things that are on the calculator here, just to kind of show you these things. I have to go back in and get my calculated values again because it won't let me scroll down. You notice there's a little arrow here. So n is like the number of data values, but that arrow means you can keep going. There's more stuff here. Look at this. We've got the minimum, we've got the maximum, we've got the median here, and we've got the first and the third quartiles. Remember doing box and whisker plots? Well, here's all the information we need for like a box and whisker plot. Okay? Even something like the range, really easy to find right here because now it kind of sorts all the values for me. And that might not seem beneficial, but if you have a list of data values that's pretty extensive, one of the things that really stinks about the median is writing all this in order, it's sorting all the data. Using a calculator or a computer program to do that for us works really nicely. And so when you have lots of data values, letting a calculator do the median for you is pretty fantastic. Even finding the minimum and maximum can be nice in order to find the range, okay? So again, you go to stat, edit, put your list in, then stat, calculate one variable statistics, and it will give you all of these values, okay? For our purposes, the sample standard deviation is this first one, is the S. Sigma is for population, okay? Couple of the really quick things on the calculator here, if we take a closer look. We kind of pointed out some of the stuff that it gives us. Obviously, we were focused on variance and standard deviation, but notice there's a little arrow here. That means there's more stuff listed. If you continue to scroll down, you'll also see right here the median is 111. You'll see the minimum, maximum, the quartiles. Remember when we do stuff like box and whisker plots. So there is a lot of information given here. The other thing that I want to point out is, remember when we calculated this originally, we decided that 189 is actually an outlier when we kind of looked at the mean originally. And that's why something like the median might be a better measurement. But that also is going to skew our standard deviation. So one of the nice things about using a calculator of some kind is if I kind of clear this out, I can easily go back to the stat menu, and I can remove that outlier so that I can calculate things without it. It's a lot easier to recalculate everything. Instead of having to punch all these values in again, I can simply delete that value. Now that value's gone. I'm down to 7 data values in my list here, and I can go right back to stat, over to calculate, one variable statistics again, and there it is. Everything is recalculated without the 189, and it's very little work to do that. So it's a lot easier to recalculate things. I've got my new mean. I've got my new standard deviation down here, the 11.56, and then I could go calculate my new variance as well. Okay, but likewise, the other things, I got my new median also, okay? And so when we do things on the calculator, it's a lot easier to recalculate things if we find we need to eliminate a value like an outlier, okay?